In the previous class, we have been discussed about the different types of vectors. Then, now in the today's class, we have to discuss about the vector addition. Addition of two vector is not a simple process. Addition of vector is always a complex process, or it's also called as a tricky phenomenon. To add the vector, we have to go with a different process. Among the first one is called as law of vector addition, in which the first one is called as triangular law of vector addition. Triangular law of vector addition. Vector addition. Triangular law of vector addition. Let us consider the two vectors which will be, let us consider two non-zero vectors. Statement for the statement for triangular law of vector addition. The statement for the triangular law of vector addition. Let us consider two non-zero vectors, two non-zero vectors. Let us consider two non-zero vector. That is nothing but what? It has certain magnitude. Because zero vector is the one where it has a zero magnitude. But we're not going to be consider any zero magnitude vector. That's why we consider the two non-zero vectors are represented by the two sides of the triangle. Two sides of the triangle taken in same order. Taken in the same order. And the third vector which will be taken to the closing side of the triangle, which gives the resultant. The third vector gives the resultant. Okay, at the closing side of the triangle. At the closing side of triangle is called triangle law of vector addition. Triangular law of vector addition. It is called as a triangular law of vector addition. Triangular law of vector addition. So here, let us find out how to go with this triangular law of vector addition. Let us consider a one vector according to the diagrammatic representation. Here we go with. Consider two vectors. Say this is a vector A. This is the tail of the first vector, which will be taken at this point as a O, and I will write this one as what? And a vector A. And this will point as A. And this is the arrowhead. This is the first vector. Then the another vector which will be considered in the same order, which will be taken in the same order. So this is the another vector we consider. This is second vector we considered. So this is vector B. So this is the vector B. So this is B. We point as a AB will represent the second vector as a B. OA represents the first vector. Then the third vector, which will be taken as the closing side towards the closing side of the vector. So this will gives you what? Triangular law of vector addition. So this is we call as the triangular law of vector addition. So this will called as a resultant as a R is equals to A plus B. This is vector A. This is plus vector B. So this is called resultant of the two vectors. It makes an angle over here. So this angle is called as a alpha. Then here we can write the condition which is related to the vector addition is, therefore, hence we can write as now. Hence we can write vector OA is equals to, see, vector OA plus vector OA plus vector AB plus vector AB is equals to vector O. You remember? So this is the first point. And there is a second one we have, there is an OB. So where OB will use you what? And a resultant as a R. So that is OB vector. So this will be, so this as the one which will have the both magnitude as well as the direction. Then we can write as the vector OB. So hence this will be going to be read as a, this will be read as what? And the resultant of a two vector. This will be called as the resultant of two vector. Now let us consider OA represents, see, OA represents and a vector A. Then AB represents and a vector B. And here OB represents an resultant of a given two vectors. Then finding the magnitude and the direction. Finding the magnitude and the direction. Finding magnitude and direction. Finding magnitude and direction. Finding magnitude and direction here. From the given figure, as we discussed in the yesterday's class, if when the angle is formed here, when this arrowhead will meet with the tail of the another vector, there is an external angle. So there is an external angle will be formed here. So this will be external angle we considered, and there is an extension we taken. Okay, and this angle will be called as a theta, and I will write this one as a n. Draw perpendicular, so just extended part. So drawing there is a bn perpendicular to this line here. Therefore, now from the triangle, finding the magnitude. So first case, finding magnitude. For magnitude, there is a triangle. So which triangle we consider? There is a small triangle ABN. See here. From this triangle AB, we consider this only magnitude. We are not considering there is a vectors. Okay. From triangle ABN. From the triangle ABN. Then first one, cos theta. Apply the condition. We know that cos theta is equals to, what is the condition for the cos theta? This is we call as a hypotenuse. Then cos theta is equals to adjacent side by hypotenuse. Therefore, so here this is we call as a opposite side, and then this is a hypotenuse. We call this one as what? And a hypotenuse. And this is we call opposite side, and the remaining is what we have. This is adjacent side. Adjacent what you have AN. So this is AN is called as a adjacent side. Hypotenuse is AB. Hypotenuse what you have. This is called as a AB. only we considering the magnitude. Only considering the magnitude. Remember, don't be get confused. We are using only magnitude, not the vector analysis over here. Only we consider the magnitude. Then we can write cos theta is equals to an divided by the value of AB. I will write the diagram once again over here, so you can come to that easily. It is. So this is the corresponding figure. I am going to just referring over here. So remember, this is the figure we are using, and this is the B, this is A, and this is alpha, and this is we call as the theta. This is N, and now here this is the point where we are going to be using O, and this point as A, and this is B. Only we are using there is a magnitudes. Okay, remember, only we are using the magnitude, but not the exact direction, because here we are only finding about the magnitude associated with the given two vectors. Okay, in case of what? In a triangular law of vector addition. Got it clearly now? Okay. Then here, once you consider cos theta is equals to AB value. AB value is how much we got, and a B. So this is B, which is implies that. Then make a cross multiply. An is equals to, we got the value of An is equals to what again? There is B cos theta. Say this is equation number 1. Remember, so here we considered the triangle which is going to be taken as what here? This is the triangle we considered. Okay, so this triangle we considered. Only the shaded part of the triangle is considered over here. The shaded part of the triangle is considered. Okay, here A, B, N. An is equals to this part. An is equals to what I get now? B cos theta. Similarly, we go with the sin theta. Sin theta is equals to opposite side by hypotenuse. Opposite by hypotenuse. Which is the opposite side you get? Bn. Bn is the opposite side. Bn is the opposite. Then hypotenuse once again, that is AB. AB. Then make a cross multiply. Then what is the value we can get here? Sin theta. Sin theta is equals to Bn by B. Then which implies once again what you get now here? B sin theta. This is B sin theta. B sin theta is equals to, it is Bn. Say equation number 2. Say this is equation number 2. Then finding the corresponding resultant associated with the two vector. The resultant can be found out. How it is by considering the triangle from total one. From triangle, which is the bigger one here? See, OBN. From this big triangle now, apply the Pythagoras theorem. Which is the biggest triangle we have? It is from OBN, from triangle OBN. Apply Pythagoras theorem. Apply Pythagoras theorem. Applying the Pythagoras theorem, what do you get? Hypotenuse square, because we need the resultant. So there is a, what is that? Hypotenuse square divided by, this is base square and this is height square. Then what do you get here? OB square. OB square is equals to, then total ON square. ON square plus, then BN square. BN square. You see, ON is the combination of what? How many quantities? Two quantities. OA plus ON. OA plus ON gives you what? OA. See, OA plus AN. OA plus AN gives you ON. See, totally ON divided into two parts. One is OA, another is AN. Like this. I can write as a ON. OB square is equals to, this is OA plus AN. OA plus AN whole square plus BN square. You know very well OB. OB is the resultant of the two vectors. Then only we consider the magnitude, that is R square is equals to OA. O to A. O to A is nothing but what? Only A. We get as A plus AN. AN is already we found. What is that? B cos theta. B cos theta b cos theta whole square plus bn. Bn, how much we got here? B sin theta whole square. B sin theta whole square. Then this will be similar to that a plus b whole square is equals to a square plus 2ab plus b square. Use this formula here. Then resultant r square is equals to a square plus b square cos square theta plus 2ab cos theta plus b square sin square theta. Then you see what is common term. We find out the similar terms over here. See, this is b square cos square theta, b square sin square theta. We have two similar terms over there. B square, b square. Make it one side. What do you get now here? Say this is r square is equals to a square plus this is b square cos square theta plus b square sin square theta plus 2ab cos theta. What is common here? B square is common. Take outside. R square is equals to A square plus B square into cos square theta plus sin square theta plus 2AB cos theta. Cos square theta plus sin square theta. So this value is equals to 1. Sin square theta plus cos square theta is equals to 1 according to trigonometric functions they are using there. Therefore, resultant r square is equals to a square plus b square plus 2ab cos theta. Therefore, we need the resultant. So therefore, r is equals to under root of this is a square plus b square plus 2ab cos theta. So this is we call the resultant associated with the given two vector. There is a magnitude of the two vectors. Then next one, finding the direction. Here we consider there is an two vectors. There is a one vector which is going to be taken in one direction, another is taken in the same direction. The third vector which will be formed as a closing side. That closing side will give you what? And a resultant. Therefore, similar to this, by using this analysis, we calculated the resultant which is going to be related to the two vectors. Then finding the direction which is going to be taken as this one by using this relation by triangle, that is OBN. So still we can use the same figure to calculate the corresponding direction associated with the given vector. Now here sin theta divided by, you divide both the conditions. So that is what you have. Divide equation 2 by 1. We get for direction. We have for direction dividing equation 2 divided by 1. We get equation 2 by 1. What do you get now here? For to get the corresponding condition. So here we get there's a tan alpha. For this angle, we have to find out. So tan alpha is equals to, for this angle we considered, for tan alpha is equals to sin theta by cos theta. But here, this angle will be called as what? An alpha. This is the resultant which is going to be occur due to an overall. And hence, we find the corresponding direction related to the two vectors. Therefore, tan alpha is equals to, so tan alpha is equals to, we get there is a sin theta divided by cos theta. Or you can go for the same analysis for this by using the tan theta value that's become more easier than the given condition. We can also apply here tan alpha for direction. We can write for direction tan alpha is equals to opposite by adjacent side. Opposite side is what? Bn. Opposite side is Bn. Adjacent side is An. Adjacent side is An. Bn by Bn divided by An can be. See, this is right. On can be written as OA plus An. And now here tan alpha is equals to Bn. So Bn value will be, so Bn already we calculated the value of Bn is B sin theta. So this is B sin theta divided by OA. O to A is considered as a plus. An is considered as a B cos theta. So this is B sin theta divided by A plus B cos theta. So hence alpha is equals to tan inverse of B sin theta divided by A plus B cos theta. This is we call the direction associated with the two vector. In few textbook, this can be written as what in other way, that is alpha is equals to tan inverse of P sin theta divided by P plus Q cos theta. They can use the two vector notation as the P and Q. They may use the notation as the P and Q. In case of A and B we are using, there is a upper one relation will be satisfied. In case of there is a P and Q, their notation is used, this relation is going to be satisfied. So this is we call as the corresponding direction associated with the two vectors. Next we have there is the special cases which is related to the vector addition. When two vectors which are going to be moving in a same direction, in a same plane. When two vectors are there in the same direction, then corresponding angle will be, same direction means theta will be equals to how much? 0. Theta will be equals to 0. Then the condition is applied to find out the corresponding magnitude and direction linked with the two vectors. And another condition is what? If they are going to be anti-parallel to each other, it means they are moving opposite to each other. Then theta is equals to how much you have? Theta is equals to, one will be in 0, another is will be 180 degree. That is minus 180. There are two conditions will be obtained there. Now the case number 1. So here we have the case number 1. The case number 1. The special cases. When two vectors are acting in, when two vectors are going to be acting in the same direction. When two vectors acting in same direction. When two vectors are acting in a same direction. Consider. Now the notation, now slightly I am going to changing the notation to become a perfect. Now I am going to be using, say this is the vector P. Say this is the vector P. And this is the other vector we are using as a vector Q. PQ. But the derivation what we proved as a square plus b square plus 2ab cos theta. Now here we are using the notation as a P and Q. So therefore, if you are using this notation, if both are going to be moving in the same direction, then corresponding angle between the two vector is, angle between two vectors is theta is equals to 0 degree. Theta is equals to how much we get? 0. If they are going to be in the same direction, angle is 0. Then we know that sine 0 degree is equals to 0 and cosine. So cos 0 degree is equals to 1. We know that the first resultant of two vector can be given as resultant of two vectors is, that is r is equals to under root of p square plus q square plus 2pq cos theta. P square plus q square plus 2pq cos theta. We know the cos theta. Theta is how much it is? 0. R is equals to under root of, this is p square plus q square plus 2pq cos of 0 degree. Cos 0, 1. Substitute here. So resultant R is equals to under root of p square plus q square plus 2pq, because cos 0 degree is equals to 1. Then 2 whole square. The square and root will be cancelled. The resultant of two vectors, when they are in the same direction, we get p plus q. Then we need to go for the direction. For direction, we have, for direction of two vectors, so that is alpha is equals to, so tan alpha is equals to, we get, there is the direction for which we get, there is the q sin theta divided by p plus q cos theta. That is, we used b sin theta divided by a plus b cos theta. Therefore tan alpha is equals to q. Keep it as it is, q into sin 0. You know very well sin 0. So this will be sin 0 degree divided by p plus q cos 0 degree. Hence alpha is equals to 0. So this is the corresponding direction. When both vectors are in the same direction. When both vectors are in the same direction. This is a case 1. In the case 2, if two vectors are mutually perpendicular to each other. Case 2, if two vectors are mutually, perpendicular to each other. If two vectors are mutually perpendicular to each other. Say for example, if this is the vector we considered, say this is the vector p and this is the vector q, and both are going to be perpendicular to each other. Say this is the vector p, this is vector q. So both vectors are mutually perpendicular to each other. This is we call as a resultant R, and it makes an angle over here. This angle will be considered as what? An alpha or maybe theta. You can, but theta already we are using. I will use this one as what? Alpha. Now, see, apply the condition now. If for resultant we can use the condition now here. So theta is equals to how much now? 90 degree. Theta is equals to how much we get? 90 degree. Then sin 90 degree is equals to how much we get? Maximum. It is 1. Cos 90 is equals to 0. Therefore, the resultant R is equals to under root of, this is p square plus q square plus 2pq cos theta. Therefore, R is equals to under root of p square plus q square plus 2pq cos theta. Theta will be, see the 90 degree, cos 90, we get this is cos of 90 degree, cos 90 is 0. Therefore, resultant is under root of p square plus q square is the resultant. When two vectors are acting mutually perpendicular to each other. Then direction associated with this vector is alpha is equals to, or tan alpha is equals to, tan of alpha is equals to, we get, there is apply same formula, q sin theta divided by p plus q cos theta. Then tan alpha is equals to q, keep it as it is, sine 90 degree, sine 90 degree divided by p plus q cos of 90 degree. Sine 90, this is equals to 1, this is equals to 0. Therefore, we get this is q divided by p. Then for alpha is equals to tan inverse of q by p. Q by p. When they are mutually perpendicular to each other. So this is the case 1 when two vectors are going to be in the same direction, and then when the two vectors which are perpendicular to each other. In the case 3, if two vectors are going to be having same magnitude, and the angle between them will be theta. In the case 3, we go for magnitude of P and Q. Case 3, if magnitude of P and Q are equal. P and Q are equal. This is the third case. And angle between the two vector is theta, and angle between them is theta. That's all. It means the two vectors, say for example, the vector P and vector Q, they will have the same magnitude. It means P is always equals to how much it is? Q. The condition is given. And both the vectors are making an angle of how much it is? Theta. Then apply the resultant. What the result we can apply? R is equals to under root of P square plus Q square plus 2PQ cos theta. P square plus Q square plus 2PQ cos theta. P is equals to what we can write? Q. Q is equals to we can write as a P. It means both will have the same magnitude. Writing any one it is doesn't make any difference. Then R is equals to under root of this is P square plus 2P cos theta. R is equals to under root of P square plus P square 2P square plus P into P square into 2P square cos theta. Then resultant R is equals to under root of, here we have 2p square as a common. We can write as a common. 2p square as a common, 1 plus cos theta. Then resultant R is equals to under root of 2p square into 1 plus cos theta gives you 2 cos square theta by 2. 2 cos square theta by 2. The value of the 1 plus cos theta is equals to what? 2 cos square theta by 2. Because I will write this one as what here? Because 1 plus cos theta is equals to 2 cos square theta by 2. This is a function. Okay. Therefore, 2 to the 4. R is equals to under root of 4 into this is under root of P square into under root of cos square theta by 2. So now root of 4 is 2. Resultant R is equals to 2. Square root will be cancelled. This is 2p cos theta by 2 is the corresponding resultant. Then finding the direction. For direction we have, that is tan alpha is equals to q sin theta divided by p plus q cos theta. P plus Q cos theta. Therefore, now we can write this tan alpha is equals to Q can be written as P into sine theta can be written as, the sine theta can be written as, or you can write one more step as it is. So P sine theta, to make a simplification, we go for one more step. So P as it is, P plus Q can be written as, once again as a P into cos theta. What is common in the denominator? P is common. P into sine theta divided by P is common, 1 plus cos theta. Then P from numerator and denominator will be cancelled. Then we get sine theta. Sine theta divided by 1 plus cos theta. You see, 1 plus cos theta can be written as 2 cos square theta by 2. 2 cos square theta by 2. Half angle. Can we write sine theta as a half angle? Yes, we can write as. That is sine theta is equals to, remember, the trigonometric function. So sine theta can be written as 2 into sine theta by 2 into cos of theta by 2. Remember this condition. 2 times of sine theta by 2 into cos theta by 2. Remember. Then substitute in the equation. Tan alpha is equals to 2 into sine of theta by 2 into then cos of theta by 2 whole divided by, this is 2 times of cos square theta by 2. Then 2 ones are will be cancelled. 1 cos theta by 2 and 1 cos theta by 2 will be cancelled. Then we get tan alpha is equals to sine of theta by 2 whole divided by cos of theta by 2. We get, that is, tan alpha is equals to, this is the tan of theta by 2, because sine theta divided by cos theta is equals to tan theta. Hence, by equating, we get alpha is equals to theta by 2. This is the corresponding resultant. Okay, now here, as we discussed in the yesterday's class about the so many conditions, about there is a types of vectors and all those things. In MCQ questions, about the MCQs, how they are going to ask the question. So first let me go with one example over there. So now, so first MCQ. So MCQ, multiple choice question now. Here, angular momentum is the first one. Angular momentum is momentum. So remember, so after this is the vector addition is for triangular lies over. Now we go with slight numerical based condition, what we discussed yesterday now. So first question, what is that? Angular momentum is, the option number 1, what is given is scalar. Number 2, axial vector. Number 3, there is a third option, polar vector. And number 4 is none. Now we choose which is exactly the right answer for this first MCQ, because angular momentum, remember angular momentum, the rotating effect produced by the polar, which is produced by the polar vector is called as what? An axial vector. It means angular momentum is the best example for what it is? Axial, yes, vectors. It will rotate about its own axis. See, so rotating at top is the best example. Okay. Similarly, scalar having only magnitude. Only magnitude, but angular momentum having magnitude plus direction. It means no scalar quantity. Polar vector produces the straight line effect it is, but it is also rotating here. So only it will going to produce a straight line effect. Hence, it is also not possible. Of course, the remaining only one answer is correct. That is axial vector. Okay. The next one. By using the rectangular coordinate components, as I discussed in the plane, that is by using an I cap, j cap, and those are called as what? And a unit vectors which will be acting along x, y, and z axis. The unit vectors which will be acting along where? About x, y, and z axis. That we have to be calculate now. The position of a particle in a rectangular coordinate. The position of a particle. The position of a particle in a rectangular coordinate is given as, that is 3 to 5 coordinate system is 3 to 5. Then how do we denote this? The option is given as, the option 1 is given as 3i cap plus 2j cap plus 5k cap. Then option 2 is given as minus 3i cap plus 2j cap plus 5k cap. Then option C, this is 3i cap minus 2j cap plus 5k cap. And option 4 will be none. Then how do we represent? See, in the rectangular coordinate system, so this is we call as the y-axis, this is z, and this is x. Unit vector always acting here is I cap. Then unit vector acting along this guy is given as j cap, and unit vector acting along this is given as k cap, and this will be as a starting point as a O. The first 3 unit, the object is moving along this direction is given as 3 times of I cap. The next 2 unit will be moving by the vertical axis. Then this will be given as 2 times of j cap. And the last one, this is a 5 unit will be moving along the k axis. So that is about z axis is given as 5k cap. It means option number first is the correct one. So now remember, this is the condition which is going to be related to the given question. Now here, which of the following is a vector quantity? You remember, which of the following, which of the following, which of the following is a vector quantity? Which of the following is a vector? Can you going to be note down the things there? Surface tension. Second one, the second option is what? There is a moment of inertia. The third one we have pressure. Fourth is none. Remember, surface tension, you just take this as assignment, and now you can just substitute and find out the answer and post your answer in the next class. If you have any doubt, we can ask. student has been given a very accurate and a good answer, and that is the answer is none. Very good, excellent answer. And because surface tension is always going to be defined as it's a force per unit length. Surface tension is given as what? Force per unit length. Moment of inertia. Moment of inertia is given as what? In terms of, is a product of mass times the square of the distance. Pressure is equals to force per unit area. Because you remember surface tension, moment of inertia, pressure. All are which quantities these are? Yes, that's all. And we got there is an excellent answer given by one of the student. Thank you. Vectors, there is an, we have two vectors which will moving in a same direction. Say this is the first vector, say this is vector P, and this will be the second vector as a Q. Both are in the same direction. If both are in the same direction, angle between the two vectors is about 0 degree. If 0 degree, then resultant can be find out. R is equals to how much you get? That is P square plus Q square plus 2PQ cos theta. Cos 0 is equals to how much you will get? 1. Then cos 0 is equals to 1. Then R is equals to under root of what you get? P square plus Q square plus 2PQ. Then A square plus B square plus 2AB. R is equals to under root of P square. So the B plus Q whole square. Square and root will be cancelled. Then resultant what you get? R is equals to P plus Q.